Hey everybody, welcome to Chapter 7, Section 4, Transformations of Logarithms. In this video, we're going to look at graphs of logarithmic functions and identify things such as their transformations, as well as their domain, range, and where the asymptote is located. So for all these graphs and functions that we look at, we're going to be referring back to the parent function of the logarithm, which I wrote is technically log base e of x, but it's always written as ln x. Remember, that means the natural log, okay? So yeah, anytime you see ln, it means log base e. And so here's the graph. Here you can see, if that confuses you, they're the exact same thing. Anything log base e is natural log or ln. So looking at this graph, you'll see it's the exact opposite of what was in the previous chapter, which was exponential functions. It looked like that. So this looks like it was kind of like flipped on its side. Really, it's the inverse, so technically it was reflected over the line y equals x, which is that diagonal line that I poorly drew right there. So let's talk about the domain and range of the natural log graph. It's got a domain of x is greater than 0. That is because it has an asymptote at x equals 0, or the y-axis. The y-axis is the line x equals 0, okay? But you know there's an asymptote there because it's avoiding, you have this waterfall effect right here. So it's basically avoiding the value x equals 0. If x could equal 0, then what we'd have is a graph that would start at 0, 0, and then go like that. It would look a lot like your square root graph. But yeah, so that's how you know you have an asymptote, where it, like I said, it waterfalls trying to avoid hitting a value. So we have our domain as x is greater than 0, not greater than or equal to 0, but strictly greater than 0, because you cannot equal 0. You have an asymptote at x equals 0. Your range, however, is all real numbers, because the range can go up. As you can see, it's trailing off up and to the right here, and then it's going down and to the left, and it is going leftwards. It's just getting closer and closer to the number 0. So we're talking like infinitesimally closer. You could have like 0.000000001 or whatever, but it's still not the number 0. So yeah, the graph's going up and down. That's the point I'm trying to make. So you have a range of all real numbers. And then when we do our transformations, no matter how the graph is reflected, your range will always be all real numbers. Like if you reflect it across the y-axis, then you have a graph that looks something like this. It's still going up and down, so it's all real numbers. If you have, if you reflect it, let's say the other way, and it goes like that, an x-axis reflection, it's still going up and down, so it's all real numbers. And if you were to reflect it both ways, it's still going up and down, so the range is always all real numbers. It doesn't matter if you translate something left, right, because that could affect the domain, but it's not going to affect the range. It doesn't matter if you translate something up or down, because if it's already all real numbers and you went up or down a few units, it's still going to be all real numbers. And you know, vertical stretches or compressions, those don't affect the domain or the range. They more so affect just the appearance of the graph. So yeah, domain by default is x is greater than 0. That can change, but the range is always going to be all real numbers. So in this section, I just kind of summarize the transformations of your logarithmic equations. We've done transformations from chapter 1 through, this is chapter 7 now. So they're all pretty much the same. Remember, if you're adding or subtracting on the outside, it'll go up or down. If you're adding or subtracting on the inside, look for parentheses. It'll go left or right. Remember, minus goes right, plus goes left. If you want to reflect something across the x-axis, you add a negative on the outside of it. And if you want to reflect something across the y-axis, you put the negative on the inside by the x. And vertical stretch, you'll be multiplying a number greater than 1 on the outside. So for example, y equals 5 ln x is a vertical stretch by a factor of 5. Vertical stretching makes the graph skinnier. So the other way to make a graph skinnier is to horizontally compress it, like push on it from the sides, if you will. And that's if you multiply a number greater than 1 on the inside of the function. So if I had y equals ln of 5x, that would be a horizontal compression by a factor of 1/5. Remember, you always have to flip those factors when you're talking about horizontal stretch or compression. Next would be the vertical compression. That would make the graph get wider. That's when you multiply a number less than 1. And by less than 1, I mean between 0 and 1. We're talking about positive numbers here. If the number were negative, you'd have like a vertical compression and then like a reflection of sorts. Okay, so I'm talking about like 1/5 on the outside. That would make it vertically compressed by a factor of 1/5. You never flip the factor for the vertical compression or stretch. You do flip the factor for horizontal compression or horizontal stretch. Horizontal stretch would make it get wider. You're like pulling on the sides of the graph to stretch it out wider. And that's when you multiply a number less than 1, again a positive number, on the inside. So if I had ln of 1/5 on the inside, it would be a horizontal stretch by a factor of 5. So that's just a recap of all the transformations. Next, I'll do 6 examples, and then what I'll do is I'll graph these off camera, and then I'll go over each one like that to kind of save some time. Okay, so for all these examples, I'm going to base the transformations off of the parent function f of x, or y equals the natural log of x, and that's going to be the red graph on all my screen grabs here. So I'm going to go over the transformations, and then I'm also going to go over the domain, range, and where the asymptote is for each of these examples. So firstly, let's start with the transformations. There's a negative on the inside of parentheses here, so that's going to make it reflect across the y-axis. You can see it's the blue line going to the left here. And then if you add 4 on the outside, that'll make it go up 4 units. If you look closely, you'll see this goes through -1, 0, and then it goes up 1, 2, 3, 4 units. So for up 4. Next, let's talk about the domain and range. My domain I have is x is less than 0. Because remember, it was by default x is greater than 0. It's going to the right. Now the graph is going to the left. So it still can't hit the 0, so there's still an asymptote at x equals 0, but it's going to the left, so your inequality sign should point to the left. And like I said at the beginning of the notes, your range is always all real numbers. It's still going up and still going down. On example B here, I have 3 transformations. I have a negative on the outside, which will reflect it across the x-axis. And so it's going to be kind of confusing. I graphed each transformation as I read the problem from left to right. So here's the red one, and that's the original. And then the green one is going to be my reflection across the x-axis here. And so they should look like mirroring images, and except now it's going down. And so then I had a 2/3 on the outside, so that's multiplying by a number smaller than 1 on the outside, so that's a vertical compression by a factor of 2/3. And so that's going to make the graph look a little bit like, if you were talking about like parabolas, it'd look a little wider. So what we have here is a graph that's not quite as tall, I guess you could say. Like the green one's going farther down than the purple one, and the purple one's the vertical compression. And then here I have the -2, and you can see that it's been shifted down 2 units. You can see it's going through 1, 0 here, and now it's going through 1, -2 there. And so my domain is still x is greater than 0 because the graph is still going off to the right. The range is always all real numbers. And so even though the graph is going down, it still has the same asymptote. It's still avoiding the x equals 0 line. All right, so in example C here, I have 7 of ln of x plus 2 in parentheses plus 1. So that's 7's multiplying on the outside. It's bigger than 1, so it'll vertically stretch it by a factor of 7. Here, the original's in red again. So the green one is just with the 7 on the outside, and you can see it's much taller, like you just pulled on the graph. The plus 2 is on the inside of parentheses, so that's going to make it go left 2. So you're going to look at this green graph, and you can see it goes left 2 units to get to the purple graph. And then I wrote plus 1, and so that one's a little hard to tell that it went up 1, but you can see that it looks like it's a little bit above the purple one, and so that's kind of what you're looking for, because we didn't vertically stretch it some more, so therefore it had to have shifted upwards. So the +2 on the inside made it go left 2. That moved your asymptote to x equals -2, because it used to be x equals 0, and then you went left 2 units. So x equals -2 is your asymptote, and since the graph is still going to the right, you say x is greater than -2. And like I said before, your range is always all real numbers because it's going up and it's going down. All right, so on example D, I have ln of -x minus 4 in parentheses, and then I have -2 on the outside of parentheses. So reading it from left to right, the negative on the inside is going to make it reflect over the y-axis. And so here you see the original in red, and now the new one's in green, going off to the left now. And then the -4 is going to make it go right 4, but it's going to look like it goes left 4. Here you can see it's going through -1, and now it's going through -5. That's because it ordinarily would go right 4 units, and then if you were to reflect that across the y-axis, now it looks like it's going left 4 units. So you still say it goes right 4, and the reason why you don't say left 4 is because of that y-axis reflection that came before it. And then after that, it's just -2 on the outside, so it goes down 2 units. You can tell that, sometimes you can tell these pretty easily by looking at where the curve is passing through -5 here, and then it goes through down 2 units, and it's passing through right there, and the black final graph right there. So my asymptote is at x equals -4, and basically the graph cannot go to the right of -4, but it can go to the left of -4. So that's why you say your domain is x is less than -4. And again, you can also think of it like this. The sign points to the left, and the graph is going to the left. Also, the range is all real numbers because it's going up and down. Okay, on example E here, I have a negative on the outside, so that's going to make it reflect across the x. You can see the original, it's covered up by the picture right there, but the original is going up, and then the new one's now going down. You have a 2/3 on the inside, so that's going to be, it's less than 1, so that's going to be a horizontal stretch. And so that's going to make it look like it's getting wider or not quite as tall. And remember, since it's horizontal, you flip the factor. So you say horizontal stretch by a factor of 3/2. And so if you look, we're going to compare the green and purple graphs. And so the purple graph is not quite as tall as the green graph. That's because it's been horizontally stretched, like it's been pulled on from the sides. And the +1 is on the outside of parentheses. So that simply just makes it go up 1 unit. And you can see that this graph, the black graph, is higher than the purple graph. So the +1 had to have shifted it upwards, right? So we're looking at the black graph for your domain and range. You can see it's still not able to go left of x equals 0. So my asymptote x equals 0 stayed in the same place. The graph is still going to the right, so you say x is greater than 0. And the graph is still going upwards and downwards, so I have a range of all real numbers. Okay, so for my final example, I have ln of 11/5. The numerator is greater than the denominator, so therefore I am going to have a number bigger than 1, and I'm multiplying it on the inside. So that's going to make it get a little bit taller looking. So that's going to be a horizontal compression since it's on the inside. And since it's horizontal, you got to say the reciprocal of the number for the factor. So you say horizontal compression by a factor of 5/11. And then the -3 is on the outside, so it goes down 3 units. And so here you can look at the graphs. This is going to get horizontal compression like you're pushing on it from the side, so it's getting a little bit taller. And then you just transfer it 3 units down to make this black graph. How's that going to affect my domain and range? Well, you can see that it still has an asymptote at x equals 0, and it's still going to the right of it, so x is greater than 0 for the domain. The range is still all real numbers because it's going up and down. And so with that, these notes are done. So thank you for watching. Hope you learned something, and goodbye.